Hey everybody, and today's lesson is over the quadratic formula. You will come across problems that aren't easily factorable or done by complete the square. And the quadratic formula is the way that you would solve these problems, okay? So I may give you a specific problem and say solve by the quadratic formula. Now what I mean when I say the quadratic formula is this big equation here. The answers, my x-intercepts, are equal to the negative b plus or minus square root of b squared minus 4ac divided by 2a. Now, if that looks a little overwhelming, I really understand that because it's a long formula. However, if you take a look here, this is the formula sheet that you will get at the end of the year on the big milestone test. This is analytic geometry formula sheet, and you'll notice, first off, on the top right-hand side, it says quadratic equations. You're given both standard form and vertex form, and then right below that is the quadratic formula. So you will be given this on tests and quizzes. There's no need to memorize it. Alright, so again, like I said, the quadratic formula is used to find the x-intercepts, the zeros, the roots, etc. To a quadratic equation that's not easily factorable. There are two things that you need to be aware of. It must be in standard form, not vertex form, and then once we have it in this form, we are going to change it and set it equal to 0. So what I'm looking for is 0 equals ax squared plus bx plus c. Now a, b, and c are all coming from the standard form of the equation. So if I take a look, a, b, and c all belong in this equation. I have a b, an a c, and another a. That's because it all comes from the standard form ax squared plus bx plus c. So the first step is to find a, b, and c in every single equation. We're going to take these a, b's, and c's and plug them into the quadratic formula. Now you'll notice that in the formula it was negative b plus or minus, right? Okay, this plus or minus means that I'm going to have one answer where I add and one answer where I subtract. Notice that we're going to get two solutions. We've talked about this in the past that usually quadratics will have two x-intercepts. Sometimes it can have one, sometimes it can have 0, and we'll talk about that a little later in this video as well. But we need to make sure we check for both possible solutions. One of them we're going to add and one of them we're going to subtract. And then we're going to make sure that the radical sign or your square root is at the end, not in the front. So let's do an example. I have 2x squared plus 6x minus 5 equals 0. It's in standard form and it is equal to 0. So we're off to a great start. So a is equal to 2, b is equal to 6, and c is equal to negative 5. Remember to take the sign of everything in front of it. Okay? You will not ever have an x term in your a, b, and c. A is the coefficient in front of x squared, b is the coefficient in front of your x term, and c is the coefficient that is your constant. So now that I have these informations, I'm going to so I have negative b plus the square root of b squared minus 4ac all over 2a. That's the first one. And the second one is going to be the same thing, but with a subtraction instead of addition. So I take the same equation, but this time have subtraction. So everywhere there's a b, I'm going to plug in 6, and everywhere there's an a, I'll plug in 2, and everywhere there's a c, I'll plug in negative 5. So I have a negative, and then b, plus the square root of b squared, except b is 6. So let's put a 6 in there. Minus 4 times a is 2 and c is negative 5. Make sure that square root goes all the way across, and then all divided by 2 times a, and a is 2. So what we're going to do now is we're going to type that into our calculator exactly the way you see it. I would start off by doing the fraction button first, type everything on the top, and then go down and type 2 times 2 on the bottom. Now what you're actually going to see in your calculator is going to look like this. Okay, that's a problem because step 4 says that we're not allowed to have the radical in front. So what we're actually going to do is that this negative 3 is going to go in the front of the plus square root of 19. So it should be negative 3 plus the square root of 19 over 2. That's going to be our first answer. But remember with quadratics, we're going to have two answers. So let's keep working. So in this case, we're going to have all of the same information, but with a subtraction sign. So we have the subtraction sign instead of the addition sign, so type this exactly the way you see it in your calculator. Start with the N over D button, your fraction button, Write the entire top exactly, parentheses and everything, over, and then on the bottom, 2 times 2. So what you're actually going to get here is that you're going to get negative 3, oops, excuse me, I got ahead of myself there. You are going to get the negative square root of 19 minus 3 over 2. But remember, like in this problem, we were not allowed to have the radical appear first. So what we're going to do is we're going to move this negative 3 in front of this negative square root of 19. So I have negative 3 minus the square root of 19 over 2. And that's my second answer. You'll notice that these answers appear very much the same, only that one's plus and one's minus. In fact, we can actually write it as, negative 3 plus or minus the square root of 19 over 2. And this right here could be our final answer. Okay, it may appear like this, separated, these two answers, but most often you'll see it appear with this plus or minus sign. Alright, so what I'd like for you to do is try example number 2 on your own. Just remember that the number in front of x is not x, it's negative 1. Alright, so for your A, you should have 6, B negative 1, and C negative 15. Now it's our job to take A, B, and C and plug it into the two forms of the quadratic, one with the plus and one with the minus. Alright, so these are the two equations that you should have formed. And when you type it in the calculator, you're going to get 5/3 and negative 3/2. So these are my two answers. X equals 5/3 and negative 3/2. Alright, why don't you try example number 3. Keep in mind before you do that this is 3x squared minus 16x. Notice there's no c. It's actually plus 0. So what you're looking at here is an A of 3, a B of negative 16, and a C of 0. Alright, so let's go ahead and get that taken care of. Pause the video now and try to finish this problem on your own. Alright, so these are the two equations that you should have typed into your calculator. The first one will result in 16/3 and the second one results in 0. So we have two x-intercepts at 16/3 and at 0. So x equals 16/3 and 0. Alright, so let's do a word problem, a real-life word problem. A pilot of a helicopter plans to release a bucket of water in a forest fire. The height in y in feet of the water, t seconds after it's released, is modeled by the following equation. Okay, so your height is going to be y, this distance here. T is going to be time, how long does it take? So the horizontal distance is actually going to be x, which is already labeled in the picture. Basically what I want to know is at what point should I release the water in order for the water to actually fall and land on the target. Alright, so that is our job. We are going to take the first equation, y equals negative 16t squared minus 2t plus 500, to find out at what time does the water hit the ground. In order to do that, we must set the equation equal to 0 and solve for t. This is where I would use my quadratic formula, because a equals negative 16, t equals negative 2, B equals negative 2, and C equals 500. Okay, so let's put that in our quadratic formula and get the two possible answers. Go ahead and give them to me in decimal form. So by putting A, B, and C into the quadratic formula, we know that the two times at which the water would hit the ground is at negative 5.65 seconds and 5.53 seconds. However, it doesn't really make sense to have negative time. So we automatically know that this first one is not our answer, so 5.53 must be our answer. Now, most of you would think at this point that we are done. However, you need to read the rest of the problem. It says that the distance in x in feet of water is modeled by the equation x equals 91t. So at what distance should I drop it? If it takes 5.53 seconds for the water to hit the target, I know that I need to plug that in to the second equation that I've been given. So 91 times T, or 91 times 5.53, means that I need to release the water at about 503.23 feet away from the target. Okay, and that is your final answer. Not the 5.53, but the 503.23 feet. All right, now, the discriminant is really cool for one reason. Okay, the discriminant is actually just the part b squared minus 4ac. It's everything that appears in the quadratic formula under the square root. So I'm not going to tell you in the formula sheet, this is the discriminant. You need to know that. Okay, so b squared minus 4ac is the discriminant, and it will actually tell us if I have two answers, one answer, or no answers, which really means if I have no answers, I have two imaginary solutions. And the reason I write that is because in the next video, we are going to have imaginary answers. Do you remember those complex numbers we talked about? Well, this is where they're going to come into play. You can have imaginary solutions. So you need to remember, if b squared minus 4ac results in a positive number, you're going to get two real solutions. If it results in exactly 0, there's only one real solution. And if it results in a negative number, you get two imaginary solutions. Now this actually makes sense because b squared minus 4ac is under the square root. So if I end up with a negative 5 under the square root, isn't that the same thing as saying I square roots of 5? Oops, not sure what happened there. There we go. So it ends up being an imaginary because the negative under the square root. Alright, so here's a visual representation. If I have a positive discriminant, two solutions, meaning that it touches the x-axis twice. Okay, 1, if it equals 0, it has one real solution and it touches the x-axis once. If I result in a negative, then I don't touch the x-axis at all, but instead have two imaginary solutions. So let's go ahead and try to find the discriminant here. Now, b squared minus 4ac involves A, B, and C. So step 1 is still find your A, your B, and your C. Well, A is 1, B is negative 4, and C is 5. So let's take that information, negative 4 squared minus 4 times 1 times 5. So I get 16 minus 20 results in negative 4. Okay? Because the discriminant is a negative, it means that we are going to have two imaginary solutions. And that is your answer. So I want to see the negative 4, and I also want to see the two imaginary solutions. All right, let's try this one. Before you do, notice it's not in standard form. Okay, so we need to actually find out the standard form. So I can subtract 4 from both sides and make it equal to 0. Now it's correctly identified in standard form. So A is 1, B is negative 5, and C is negative 4. So b squared minus 4ac is negative 5 squared minus 4 times 1 times negative 4. So this is going to result in a 41. So 41, because it's positive, means I have two real solutions. Now you'll also notice that in the question I asked, is it going to be rational or irrational? Meaning, does my final answer have a square root in it or not? The answer is it's going to be irrational, and the reason for that is because the square root of 41 is not perfect. It's not a perfect square. Oops. Alright, so why don't you try this problem? Remember to put it in standard form first. Alright, so this is the equation that you should have done. The 4x squared plus 20x plus 25 is in standard form. But before we go too far, I wanted to throw in a pop quiz question. What is my favorite type of flower? And my favorite type of flower is a lily. So with b squared minus 4ac, I'll plug in 20 for b, 4 for a, and 25 for c. When I type this in my calculator, I get 0, which means I have exactly one real solution. Alright, so we don't have time to watch this video, but it's something a little fun if you want to watch. Alright, that's it for quadratic formula. I will see you guys later.